Hey there, welcome to VCode's 100 Days of Coding Challenge. Today is day 30 and let's see the question number 2. So the question is, write a Java program that finds the maximum sum of any subarray within an array of integers using Cadence algorithm. You will be given an array and your task is to find the maximum sum of a subarray. So we had seen the same question yesterday and we had solved using the big O of n square method. So using this Cadence algorithm, we can solve the same question, but this would be much more efficient solution, while the time complexity will be big O of n, which is a linear time complexity. So the function description is given, the return type is int, name of the function, we can keep it anything. So it is given find maximum subarray sum, and the input is an array. So the same thing is written here. We are given with a sample input which is an array, and the maximum sum of a subarray in this array is 7. So for revision purpose, what is a subarray? Subarray is a contiguous part of an array. So if we take the same array here, so single element can be also called an array, and the entire array can also be called as a subarray. So we can take here 1 minus 2 is a subarray, minus 2 3 is a subarray, minus 2 3 minus 4 is a subarray. But if we take the elements minus 2 3 and 5, so there is a distance between 3 and 5, that means they are not continuous. In that case, it is not called a subarray, but it is called subsequence. So we are only considering here in this question only the concept of subarrays. So that's it about subarrays. So let's quickly dive into what is Cadence algorithm and what is the approach used. So I have taken an array, so it's a quite long array. So what is the approach to solve this question using Cadence algorithm? In Cadence algorithm, the time complexity is big O of n, as I've already said. So that means we only need to iterate through this entire array only once, and by the end of the iteration, we would be having the maximum sum of a subarray. How do we do that? Here are some steps to follow. So the basic step is, firstly, we have to take two variables. So one is the maximum sum. So let me name it max sum. So this will store the max sum which we are going to return at the end. So I will initialize this with the first value of the array, which is, so let's suppose the array is A. So it will be A of 0. And the next variable is the current sum, or let me name it as sum. So this would be having the sum, sum of the subarray at present. So sum will be initialized with 0. So these are the two variables to consider at the first. We are going to use these variables. Now what are the steps? So firstly, we will start from here. So let it be I. It is the iterator. So the sum will always be updated by adding the value at the I. So here we are going to add the value at I. So sum equals sum plus A of I. But here are conditions. Whenever the sum becomes less than 0, we need to update the sum with 0. So what is the intuition behind this condition? So the thing is, here we are going to find the maximum subarray sum. Suppose here we have started from minus 2. So the sum will be updated with minus 2 and we are going forward, right? So what is the point of having minus 2 when it is going to decrease the value further? So here we don't need to consider this minus 2 and we are going to update this value with 0 again, because minus 2 is going to decrease the value of the subarray sum, and the max sum is anyways the first element. So it is minus 2 only. So let's now do a dry run here. So minus 2 is done. So now the I will go to 1. So what will happen? So is 1 greater than 0? Yes, it is. So sum will be updated with 1 and the max sum is greater than the sum. After each time after we have updated a sum each time, we need to check if the sum is greater than the max sum, because anyways we needed the maximum value at the end, right? So we need to find if the sum is greater than max sum. If yes, we need to update the max sum. Is it greater than? Yes. That's why we are going to update this -2 with 1. Okay. So now moving forward, we have -3. So we have added -3 to the sum value. So 1 plus -3 is -2. So it is negative, right? So we don't want it forward. So now we are going to update the sum with 0. So next value we have is 4. So we are going to update the sum with 4 and check it with the max sum. Is 4 greater than the max sum? Yes. So now we are going to update this max sum with 4. So on we can go. So now I have come to -1. So 4 minus 1 will become 3. I have kept it because anyways it is greater than 0. So now let me clear up this space a little bit so it will be easy to understand. So now the sum value is 3 and max sum is 4. So now we are moving forward to 2. So we are going to add it to the sum. Now the sum value is 5. And is 5 greater than the max sum? Yes. So we need to update it. So I have got max sum till now is 5. Now let us move forward. I have got 1. So we are going to add it again to the sum. So it will become 6. So is 6 greater than the max sum? Yes, it is. So update the max sum with the 6, which is the maximum till now. In the next step, we have -5. So the current sum will be updated with 1. Yes, it is still greater than 0. That's why I'm keeping it. So we can move forward. So now we have 4 here. So I will update this with 4. So 4 plus 1 will become 5, right? Yes. So we had got it. But 5 is anyways less than the maximum. So we are not updating the maximum. And by the end of the iteration, what we had got? We had got the maximum value is 6, which is exactly the maximum subarray sum of this array. So this is the approach to solve this problem. So the conditions here are, we are going to add each element to the sum. If the sum becomes less than 0, we need to update the sum with 0. Else, if the sum becomes greater than the maximum, we need to update the maximum with the value present in the sum. So those are the two conditions and the the sum we need to do. So let's quickly write this code. It is very simple. So now let's write the code. So you can see here the output is 6, which was the example I had taken. So this was the same example I had taken and the output was 6. So that's it. So I have opened the Java file. So here I'm going to write the array quickly, int arr, and I'm going to declare it with the same array. Let us take this array this time to check if it's coming 7 or not. So now I'll pass this array into the function. So find max subarray sum of arr. So now I'll need to declare the function here. So static int find max subarray sum, and here the input is an array. So let's quickly declare the variables we need to use. So int maxsum. So this is going to be initialized with the first value of the array, and then int sum will be initialized with 0. So we are going to write the iteration here. So for loop int I equals 0, I less than array dot length and I plus plus. So we are going to end till the end of the array, and so now, so at the last we need to anyways return the sum, right? So return max sum. Okay. So what is our logic here? So here we need to update the sum by adding it with the sum value at I, and then if sum becomes less than 0, we don't need that value to move forward because we need maximum sum. So we are going to again update the value of sum as 0. And after finding the sum each time, we need to compare it with the max sum. So if sum becomes greater than the max sum, then update the max sum with the sum value. And finally, we have returned the max sum. That's it. The code is very simple and the logic is a little bit tricky, but easy to understand. So that's it for the code. So now let's run the file and check. So I've opened the terminal, cadence algo.java. And now Java cadence algo. So you can see we had got the output as 7, which is exactly the maximum subarray sum of this array. So this algorithm is mostly used and asked in the interviews. So first approach is whenever the question is asked, you can go with the brute force approach, which can be done with big O of n cube, where we will consider the array. We can find all the subarrays and find the sum of each subarray, and then we can update the maximum accordingly. So that was a brute force approach. Then we did a better approach yesterday, which is big O of n square method, where we used only 2 for loops. And this approach is the most efficient way of solving this question, which is big O of n approach. This can be asked in the interviews. The interviewer may ask to optimize the code whenever you write a brute force approach, and that time you can use this algorithm. So I guess you understood the cadence algorithm, and that's it for this video. Do follow the 100 Days of Coding Challenge of Free Code. Thank you for watching.